sketch a graph of g of x equals the square root of the opposite of x plus 2 as a transformation of the graph of f of x equals the square root of x. There's actually two ways that we can go about this problem where we have these two horizontal transformations that we need to make because there's two things going on inside the radical. I want to show you both of them so that you can see how they work and understand how we have to be very careful with these problems. So let's go with method 1. All right, now the first thing that we can do here is we're going to start off with f of x equals the square root of x. And remember that we somehow have to end up with the square root of negative x plus 2. Now, one way to go about this is by replace x with x plus 2. If we do that, that gives us the square root of x plus 2. And then to go from here to here, we can replace x with the opposite of x. So this is one way that we can get from f of x to g of x, by replacing x with x plus 2, and then in this step, by replacing x with the opposite of x. So replacing x with x plus 2 is a shift left 2 units. And then replacing x with the opposite of x ends up being a horizontal reflection about the y-axis. So we can reflect about the y-axis. This is one way that we can end up getting the correct answer. And so what I want to do is I want to graph this, and then I want to talk about the other way, and I want to talk about the common mistake that students make. So firstly, we want to shift everything to the left 2 units. So we can take our 4 points here and shift each of them to the left 4 units. If we do that, that gives us this point, this point, this point, and this point. Then what we need to do is we need to reflect all of these points about the y-axis. So the points that are on the left side get reflected to the right, and the points that are on the right side get reflected to the left. So let's reflect these one at a time. This point here is 2 units to the left of the y-axis. If we reflect it, it needs to end up 2 units to the right of the y-axis. This next point is 1 unit to the left of the y-axis. If we reflect it, it needs to end up 1 unit to the right of the y-axis. The third point is 2 units to the right of the y-axis. If we reflect it, it needs to go 2 units to the left of the y-axis. We're taking each of these points and sending them an equal distance on the other side of the y-axis. And then if we look at this point here, it is how many? 7 units to the right of the y-axis. So its reflection is going to be 7 units to the left of the y-axis, which is going to be there. And then if we connect these points with a nice graph, we end up with the graph of g of x equals the square root of the opposite of x, plus 2. I'm going to quickly actually sketch in this intermediate graph just so you can see it. I think it's a little bit nicer if we do that, because then we can see how this intermediate graph and the new graph are reflections about the y-axis. One starts on the left and moves up to the right. One starts on the right and moves up to the left. They are mirror images of each other across the y-axis. Now, what I want to do next instead of looking at the second method that we can do, the second way of doing this, I want to talk about the common mistake that students make. The common mistake that students usually make is they look at the function that we want a graph of, and they look and they say, okay, there's a negative in front of the x, and then 2 is being added. So they say the negative in front of the x means that we have to reflect about the y-axis. And then the 2 that gets added means we then need to shift to the left 2 units. And students try and do the reflection first and the shift second. And that doesn't actually work. If you start by reflecting the original graph, you get something that looks like this, which has an endpoint still at the origin. And then if you shift to the left 2 units from there, what happens is the origin moves to the left 2, and you've got a graph that looks something like this, which is certainly not the graph that we know is correct. So why is this a mistake? Well, if you go through things more carefully, using the steps that we've been using, if you start off with the original function, the square root of x, and you change x to the opposite of x, and then if we want to shift it to the left 2 units from there, remember the way that we do this is by replacing x with x plus 2. If we wanted to replace x with x plus 2, but we've got that negative in front, what we're really doing is we're taking the opposite of x plus 2, and if you simplify that by distributing that negative, we end up with the opposite of x minus 2, which is not actually the function that we wanted. So the order in which we're doing these transformations matters when we're looking at multiple horizontal transformations or multiple vertical transformations. And we really need to be going through this carefully as I've been doing each example, because if we don't do it, we might end up with something that doesn't actually match the graph that we need. So, that said, I want to quickly show you the second method that we can use, because we can actually switch the order of these two things. We can do a reflection first and then a shift second, but to do this, we actually have to look at the function differently. We know that g of x is equal to the square root of the opposite of x plus 2. We could rewrite this by factoring out a negative on the inside and then having the opposite of x minus 2. If we do it this way, then we can start off with f of x equals the square root of x. We can start by replacing x with the opposite of x. That gives us our horizontal reflection. And then after we do that, to get from the opposite of x to the opposite of x minus 2, as we have here in this factored version, now we can replace x with x minus 2, not x plus 2. We can replace x with x minus 2, and this corresponds to a shift to the right 2 units, not to the left 2 units. So we actually have two options to get from our original graph to the new graph. We can either start by shifting left 2 units and then reflecting about the y-axis, Or we can start with our horizontal reflection about the y-axis and then afterwards shift to the right 2 units. What I want you to do is on a separate xy plane, give this a try. Start with the original graph, reflect it horizontally about the y-axis, and then shift to the right 2 units and make sure that you end up getting the same graph. You should be able to do that. Oops, this was method 2. I forgot to write the 2.